And we're back. So I want to make sure we all understand how a company will choose a discount rate on their investment. The minimal required rate of return would be our cost of capital. So once again, if we have to borrow money to buy equipment or any other needs, we're saying, what would it cost us to borrow this money? Maybe that's a 5% interest rate. So we're saying the minimum rate of return on our investment has to be at least 5%. We also look at, well, what's the average return that we pay our long-term creditors and stockholders? So what's the rate of return we're paying out in dividends to our stockholders? What's the average return we're paying on our other forms of long-term creditors? That might be 8%. So now we're saying, okay, to accept this project, our minimum discount rate must be at least 8%. We want to make sure that this project can cover the rate we're paying to our long-term creditors, the rate we're paying to our stockholders, and if we have to borrow money, I want to make sure that I'm at least covering the rate it costs me to borrow money. So to simplify, if I can borrow money at 5%, but then get a 10% return on that investment, then it makes sense to accept that project. Okay? So the net present value we talked about earlier provides for the return on the original investment. So let's take a look at some additional information to see whether or not we want to accept an investment. Here we have Carver Hospital. They considered buying an attachment for its x-ray machine. So as an attachment, we have an x-ray machine already, but the attachment has a cost of $3,169. It can be used for 4 years. And because of this attachment, it'll increase our annual inflows by $1,000. No investment is to be made unless there's an annual return of at least 10%. So now, do me a favor. You listening? I really want you to pause this video, work out the calculation to determine whether or not we're going to have a positive net present value or a negative net present value, and if we should accept this project. So we're going on the honor system, right? I'm going to trust that you're going to stop the video, do the calculations, and then watch the actual solution. Can I trust you? I'm sure I can. Okay, here we go. So here we take a look at the initial investment, which was for $3,169. That's going to be an outflow. Now the annual cash inflow is going to be $1,000. $1,000. Now this is the long way of doing it. There's two options. We can look at the present value of a single dollar and look at its terms. So for the first year, your number of people will be 1, rate will be 10%. For year 2, N would be 2, rate would be 10%, and so forth. Or because we're going to receive $1,000 each year for 4 years, you can look at your present value of the annuity table. You will just look at 10, and for 4 being N, when you add these 4 all together, it'll give you the total of that factor if you use the annuity table. But what we see here is that our net present value is 0. What does that mean? It means that this project will give us the exact rate of return we requested. This project will provide us with exactly a 10% rate of return. Therefore, we would accept this project because it does meet the minimum requirement. So again, this project gives us exactly 10% rate of return. Therefore, we would accept this project. We would buy the attachment to the x-ray machine because it does meet our required rate of return. Okay? Now, the internal rate of return is the rate of return promised by an investment over its useful life. If it is computed by finding the discount rate that will cause the net present value to be zero. So what we're saying is that the internal rate of return is the rate where, if used, the project will give us a net present value of zero. Okay? So we can kind of play around to see, okay, we know our discount rate, but in order for us to get zero, we can try different rates to see what would be our internal rate of return. So when the net present value is zero, that means the internal rate, the rate that you use for those calculations represents your internal rate of return. Okay? So if the internal rate of return is equal to or greater than the minimum required rate of return, we're going to accept that project. But if the internal rate of return is less than the minimum required rate of return, we're going to reject that project. So pretty much you're comparing your discounted rate to the internal rate of return. And so again, when your net present value equals zero, that is the rate that was used to get zero represents your internal rate of return. If that rate is equal to our minimum rate of return or higher, we'll accept it. But if it's less, then we're going to reject that particular project. Okay? For example, we have the Decker Company purchased a new machine at a cost of $104,320 that will save $20,000 per year in cash operating costs. So by buying this new machine, there's a cost saving of $20,000 per year. The machine has a 10-year useful life. Okay? We're trying to figure out what's going to be our internal rate of return. To do that, we'll take the present value factor of the internal rate of return. We take the investment required divided by our annual net cash inflows. Investment required divided by our annual net cash inflows. So based upon these factors, the internal rate of return will be 5.216%. So again, based upon these factors, the internal rate of return would be 5.216. We're saying at this rate, it should give us a zero net present value. The internal rate would be 5.216 would be our internal rate of return on this particular investment. Okay? So if you were to use your table and you use the present value factor to figure out what would be the actual discount rate required to get this internal rate of return, you would go to 10 periods. And that's because this machine has a 10-year return, a 10-year useful life. You would keep going under 10 until you find that factor, which in this case is 5.216. So how do I get 5.216? That's based upon a 14% rate of return. So what we're saying here is that in order to get that 5.216 factor that was shown here, we want to find the present value of that 5.216. We will look at our present value table. So the 5.216 is not the rate, that's the present value factor of the internal rate of return, that 5.216. Using your present value table, you will look up 10 periods, keep going till you get close to that 5.216. Here it is here. So we need a 14% rate of return in order for us to have a present value of zero. Okay? So if our minimum rate of return is equal to or greater than 14%, then we would accept this particular project, because to get the internal rate of return, that factor was 5.216. So if the minimum rate required rate of return is equal to or greater than 14%, then this machine should be purchased. Okay? So we can compare the net present value approach against the internal rate of return. The NPV is simpler to use. With the internal rate of return, it's going to assume that all cash flows are going to be reinvested at the internal rate of return. So for the previous problem, we're going to assume that all cash flows each year will be reinvested at a 14% rate of return. If the internal rate of return is high, this assumption may be unrealistic, but you must determine what considered to be high for your company. It is more realistic to assume that the cash flows can be reinvested at a discount rate, which is the underlying assumption of the net present value method. So what we're saying here is that you can use either approach, but the net present value approach typically will give you a more realistic numbers than if you were to use the internal rate of return approach to determine which project you're going to accept. Okay? We're going to go back to the net present value method, but we're going to include two alternatives. First, we will analyze the alternative using what's called the total cost approach. The total cost approach. We'll look at two alternatives. We'll look at all the cash inflows and all the cash outflows for each of those alternatives. Okay? No effort will be made to isolate those cash flows that are relevant to the decision and those that are irrelevant. So we're saying whatever cash inflows and outflows are going to be involved, we'll look at all of those, whether relevant or not. And then based upon those cash inflows and outflows, we'll determine the net present value of each alternative, and we'll then make a decision. For example, let's say we have the total cost approach. Here, we have two alternatives. We can remodel an old car wash or remove the old car wash and install a new one. Again, we can remodel an old car wash or remove the old car wash and install a new one. Which approach should we do? Should we remodel the old car wash or should we remove the old car wash and install a new one? Who says option one? Okay. Who says option two? Well, survey says we're going to come back and determine which approach we're going to take, option one or option two. Stay tuned for the conclusion of our Chapter 14 lecture.